Topic: electric vehicles. By my side, Andreas, our top product manager for automotive tech. You have seen the three systems in the background quite often indeed. We don't want to delve into great detail today. However, today we specifically want to specialize in the topic of diagnosis. We know all systems are perfectly suitable for the various qualifications, no matter whether it is the DGUV in Germany, the IMI qualification, or even the ASE EL3 in the USA. Each system comes with an e-learning course, and we have all measuring instruments on board. But now we should focus on the question, what diagnostic options do we have for each of the three systems? For this purpose, I have my expert here at my side, and we are starting with it. Here, we see our CarTrain designed for hybrid and electric vehicles. As said, we have already shown this in many videos. Indeed, 5 different drive systems in one system. E-learning course included, we have different measurement possibilities, a real high voltage system with 300 volts. But even here, we would like to specialize in diagnosis now. This means that the vehicle team has made something very cool possible here, that we can safely switch on various errors in a real high voltage system. Andreas, what errors do we have for this system?
The errors that we can turn on are hidden up here, right behind this particular flap. On the one hand, we have an error in the engine. This means 2 motor phases are short-circuited, where one can then carry out corresponding measurements. Can measure errors? Can we measure directly into the high timber system?
Yes.
Then, once there is a disruption in the area of the battery, which we can then find and closely examine, an insulation fault, which we can detect if the vehicle presents an insulation fault.
This is indeed a very exciting error. Many customers also ask if we're now allowed to measure into the system with the insulation tester at high voltage when it's unlocked, then find where the error ultimately is.
Exactly. The important thing is that an insulation tester is really used here, and a normal multimeter cannot find this error. One must reach the certain voltage to measure this error. Okay, understand. Wonderful. What else do we have? Then we also have potential equalization errors. On the one hand, an interruption, and on the other hand, a high resistance. This means that some manufacturers specify that grounding conductors must be measured at certain intervals. And on one hand, we have an interruption in the equipotential bonding line, which, for example, connects the component's housing with the vehicle body.
What we are seeing now are these mass connections. Not here, sorry, in these spots.
They are firmly connected to the housing. Exactly, those are the casings of the devices. And these are connected to the vehicle body. And this connection then needs to be measured. It must have a very low resistance, less than 1 ohm, depending on what the vehicle manufacturer specifies. Partially in the range of 10 milliohms maximum.
Okay, and that means, of course, it can corrode over the years or over time so that we have a transition resistance, or in the worst case, maybe during some repair or something else, that such a cable is cut, is broken, and that we then have no connection at all.
Either interrupted by a faulty repair process or by improperly and carelessly carried out accident repair work.
Wonderful. Or just corrosion, as you've already mentioned. This means we can simply switch these errors on and off by a button or a switch effortlessly. In addition, we have a permanently installed diagnostic device in the system with which we can read out various values, but above all, also the errors briefly. So we really have everything in place here, a quasi one-hand complete solution, everything from one hand, and can thus perform the diagnosis in the Hochholz system super well.